All right, eighth graders. So, 1-1A. Chapter 1 is all about combining like terms and solving expressions and equations. So, we're going to go ahead and scroll down here to the bottom of, actually, the top of page 3. And we're going to learn about equivalent linear expressions. So, an expression, if you look at the top of page here, an expression or a linear expression could be any of these ideas right here. All right. So, in my mind, a linear expression is a mathematical phrase consisting of numbers, unknown symbols that represent numbers, those are called variables, and arithmetic operations. Linear expressions describe mathematical or real world situations. In other words, they have numbers, variables, okay, there can be operations, meaning adding, subtracting, multiplying, dividing, okay. Main thing here to know, guys, is that there is no equal sign in an expression, okay. So you'll see numbers, you'll see variables, okay, you'll see adding and subtracting. That's all in an expression, okay. So it says below are equivalent linear expressions that represent MS scores. So what you're going to see is in this chapter, we can distribute in this first one that 2 times p is 2p, 2 times 500 is 1,000. So we're trying to combine our like terms here in order to find expressions that are equivalent, okay. So what I want you guys to do is read this here on your own. And I'm going to go down to, let's go here to number 2. Actually, the one before that. Okay, so here they're giving you a visual. They're saying this white box is 1, this gray box is -1. This white box is x, this gray box is -x. Remember that a positive tile and a negative tile can be combined to create a zero pair, okay, or adds a 0. So this last unit, we talked a lot about how -1 plus 1 is equal to 0, right? We can talk about how 2x minus 2x is also equal to 0. So they're just showing you here that a positive 1 and a -1 equals 0, okay? They're showing you that x plus -x is 0. Those are called zero pairs. So if you look here, it says the following is a model of the expression 5x plus -3x minus 6 plus 4. Well, if you look at this, I'm first going to show you the math. Let's talk about like terms. Well, 5x and -3x, if I combine those, how many x's do I have? Well, Ms. Fursky, I have 2x. Great. I also have a -6 and a +4. If I combine that, what will I have? Well, you might be saying, Ms. Fursky, I'm going to have -2. Great. Let's look at the visual. These and these gray boxes are zero pairs. They cancel out. So I'm left with 2 white rectangles, which represents x, right? So I have 2x. Well, if I do the same thing here with these smaller tiles, these are zero pairs, and I'm left with 2 gray boxes. My gray boxes were negatives, that's -2. Now I might be saying, Ms. Tversky, do I always have to model this expression? No. If you're a visual learner, this might be easier for you. If you're still having trouble with positive and negatives, this might work for you as well, all right? So it says 5 zero pairs, we did. Now it says evaluate this expression when x is 8. Okay, well our expression was 2x minus 2, right? Well, if you evaluate means just find the number or find the value. So if I take this 8, if they're saying x is 8, and I plug it in up here, that means I will have 2 times 8 minus 2. 2 times 8 is 16. 16 minus 2 is 14. All right, so let's try another one. Let's go ahead and try this next one. Using your tiles model this expression. I am not going to use tiles on this one, but if you would like me to show you how to do that, I certainly can do that, all right? So let's combine our like terms. I like to start with variables. So we have a -4x and a +5x. If I combine those, -4 plus 5 gives me 1. So I have 1x. Now, Ms. Fedorsky, can I just leave that as an x? Absolutely. What about 3 minus 1? Well, that's going to become +2. So 1x plus 2 or x plus 2 would be the same thing. Find zero pairs and write the simplified form of this expression. We already did. Evaluate when x is -5. So all you have to do is plug in -5 for x. So we have -5 plus 2. -5 plus 2 will give me 3. It says the following is the model for an expression. 3 times the quantity of x plus 1. Well, Ms. Fedorsky, what does that mean? If you look at this right here, x plus 1, they're showing you that this right here is x plus 1. Here's my x, here's my 1. So x plus 1. Well, now, if I multiply that 3 times, 1, 2, 3, how can I write that as a simplified expression? Well, I can distribute, right? Or I can count. I'm going to have 1, 2, 3 x's, so 3x, plus I'm going to have 1, 2, 3, 3x plus 3. You could also distribute. 3 times x gives you 3x. 3 times 1 gives you 3. 3x plus 3. Write a simplified form of this expression. We did here. Evaluate when x is -4. Well, to do that, we're just going to say, okay, well, 3 times -4 plus 3. 3 times -4 will give me -12. -12 plus 3 is going to give me -9. Okay, it says using your tiles, model the expression 2 times the quantity of 2x minus 1. I'm going to draw this one with you, okay? So hear me out. Let's start with what's in parentheses, 2x minus 1. So how could I draw that? Well, here's 1x, 2x, -1 will be shaded. All right, and there's 2 of these sets, so 2x minus 1. Right, so there's that. Now it says write the simplified form. Oh, I don't know how to get that to stick there. Of this expression. Okay, well, how many x's do I have? 1, 2, 3, 4x. And then how many negatives? I have -2. Ms. Fedorsky, is there another way I could do this? Yeah. If you look up here, you can distribute. I'm trying to change my color. 2 times 2x would give you 4x. 2 times -2 gives you -2. Now, the tiles will be helpful if you're a visual learner, all right? But if you're seeing this distributing method, you can do that as well. Evaluate the expression when x is 0. I'm going to have you do that one on your own, so B, and we're going to move down below. It says directions, model and simplify each expression. I'm not going to model for this, but I am going to solve. And if you would like for me to show you some more examples of modeling, let me know, all right? I'm thinking PEMDAS for this though. So let's go ahead and distribute. We have parentheses here. 2 times x will give me 2x. 2 times 2 will give me 4. Bring down that minus x. Order of operations, combine or like terms. 2x minus x will give me, 2x minus x is going to give me 1x or just x. Bring down that plus 4. Over here, let's look for like terms. Well, PEMDAS, do I have parentheses in here? Yes, gotta distribute first. 4 times x is 4x. 4 times -3 is -12. I need to bring everything else down. That was up there. Combine those like terms. 4x, -3x. When I combine those, I'm going to get 1x. I still have a 3 and a -12. When I combine those, I'm going to get -9. Ms. Fedorsky, is x minus 9 also an answer? Yes. Ms. Fedorsky, I got x plus 9. Remember, this -12 here, when I combine 3 and -12, that gives me a negative. Okay, I am going to have you guys do number 8 on your own, and I'm going to hop in on number 9. So with number 9, all right, I really want you to put a star next to this one. The reason why is because this negative sign right here, we're going to try and trick you. This is actually a -1, all right? Anytime you have a negative sign next to parentheses, that's a -1. So that's going to change everything in parentheses to the opposite sign. You might be saying, well, what? Well, what's -1 times x? when you distribute that -1, that gives you a negative x. A negative times a negative gives you a positive. So that's +2 plus 4x and then 12. Don't worry, we'll work on this a little bit more in class as well, okay? So when we combine our like terms, we have 4x and -x. When you combine those, you're going to get 3x. When you combine 12 and 2, you're going to get +14. Okay, so that is your work for today. We'll go ahead and press forward with 1-1A in class tomorrow. If you have any questions, shoot me an email.